Hi everyone, welcome back to the second video in tree diagrams for this week, where we're looking at tree diagrams without replacement. So the big idea and core thing of without replacement that we're looking at is our sample space decreases because we remove values from it. So say I have, let's say 5 marbles in a bag, and they're red, red, green, green, and yellow. So if I start drawing out of this bag, say the first time I want the probability of drawing a red, well, it would be 2 of the 5 is the probability of drawing a red. Now, if I draw a red, what happens is I take that out of the bag and it doesn't get put back in. So now if I want to find the probability of drawing a red again, I have 1, 2, 3, 4 outcomes and only one of them is red. So this sample space is decreasing because we're taking values out of the sample space. So we're going to see this descending order when we take values out and working on tree diagrams without replacement. We're not putting the value in. So we have a bag. It contains 8 yellow and 12 green marbles. 2 marbles are drawn without replacement. Sometimes without replacement we'll say simultaneously or consecutively or something. It should be pretty clear how this is being worked and if they're being put back in or not. What's the probability that both marbles drawn are the same color? So we need to show this in a tree diagram to start out. So what we're going to do is just say, well, here will represent my first marble, the first marble I draw, and it can be one of 2 options. My first marble can either be yellow or it can be green. And we know the probabilities of these happening also. 8 and 12 make 20. So yellow, I don't want to reduce this because it's going to get really messy. I just want to stay consistent with a unreduced fraction here. So 8 of the 20 are yellow and 12 of the 20 are green. So now let's get into the second marble we draw. So when we draw a second marble, again, because we have enough that if I draw one of these, there's still remaining yellow, there would be 7, and there's still remaining green, there would be 11, I can still have those outcomes. So we have yellow again, or we can draw a green. And similarly with the green, we can draw a yellow, or we can draw a green again. So this shows all of the outcomes of drawing the first and second marble: yellow, 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 green, green, yellow, green, green. So all the outcomes are represented of the sample space here. So now let's put the probability on the second marble. So if I drew a yellow on the first marble, now I have 7 left in the bag, and instead of 20 marbles remaining, there are 19 in the bag. Now, if I drew a yellow first, I'm going to draw a green second. I have 12 green still because I didn't draw yellow. I have 12 green, and I still have 19 in the bag. Notice the sample space is consistent. There's 19, but the number of yellow decreased. Now I drew a green first, and I want the probability of drawing a yellow. Well, there's still 8 yellow in the bag because I didn't draw a yellow first. And there's 19, there's 1 less marble because I drew a green this time. Now if I draw a green first and a green second, there are 12 minus 1, there are 11 marbles that are green of the 19. So there is our tree diagram with the probabilities assigned. So now what we want to do is work through this problem actually, and I want the probability that both marbles are the same color. So I want the probability of yellow first, yellow second. That's one way they can both be the same color. Or when we say or, we add, and when we say and, we multiply. Or I want the probability of a green first and a green second. There's where we'd multiply. So probability of yellow, yellow would be a yellow first. So I have 8/20 times yellow second. So I'm drawing a yellow and a yellow. That's why I'm multiplying here. Yellow second is 7/19. Or I can have the probability of a green first, which is 12/20. We're going this way on the branch now. 12/20. Ooh, that's 12/12. 12/20 is what we want. 12/20, and I want to draw a green second. And we multiply. Whenever you find yourself saying and, you multiply. Whenever you see yourself saying or, you add. Multiple outcomes would be adding also. That satisfies this requirement. And I want a green second, so 11/19. So now we need to add these together. Real quick, let's look at what 20 times 19 is. It's 380. So of the 380, common denominators here, which is nice, of 380, 8 and 7 make 56. 12 and 11 make 121, I believe. Oh, 132. Whoops. I don't do well on the spot here. This pressure. 132. So 56 plus 132. 188 380ths. We already have the common denominators. 188 over 380. And real quick, let's look and see if that reduces. And it reduces to 47/95. Or we could say that 188, let's not get into that actually. That's a little messy. I don't think it works out that way. So there we have it, an example of a tree diagram with replacement. Keep in mind that the denominators change because the sample space decreases every single time. So look for the final practice. Hope this video helped. Let me know what questions you have.